All right, so when we're trying to analyze a quadratic situation, the first step is to know what our x and y variables represent. So we're going to go and label our axes. So this situation is about a circus performer being launched from a cannon into a pool of water. And remember, in like physics and some science areas, we will see this notation with the h of t and the t's. You are welcome to change those to y's and x's. So this is the same as saying y, and then these t's would be x's. So then in this case, y is the height above the ground, and x is the time in seconds. So I'm going to label these on the graph. So my x-axis was time in seconds, so I'm going to say time, and that's being measured in seconds. And then my y-axis is the height. So my y-axis is height, and that is being measured in feet. So then any point along this parabola, we know that the coordinate in the x spot of the point, so just a reminder, xy. So the coordinate in the x spot is going to be the time, or we can say it's x seconds at y feet. And so that's seconds, 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 seconds in the x spot, and then feet would be in the y spot. So every xy pair along this graph is how many seconds and how many feet at that many seconds, based on this relationship defined by that equation there. All right, so then our next step, so we labeled the x and y axes, and then we're going to fill in any known coordinates. So anything that is an intercept, we for sure know one of the coordinates is going to be a 0. So I'm going to look at my graph. So I'm looking for like intercepts are where like this black parabola will cross the purple line or the green line. So where they cross the purple line are x-intercepts, and I have 2 of them there and there. So this is an x-intercept right here, and an x-intercept over here. And I know that any point on the x-axis is going to have some x-coordinate going left or right, but I'm not going up or down, so my y-coordinate is always going to be 0. So that's a for sure value that I can fill in for x-intercepts. Okay, and then kind of likewise, but thinking the other way, any value, so this black line crosses the green right there, that's the y-intercept. And I know that any value on the y-axis has some y value, but it doesn't have an x value. It doesn't go left or right. So x is always going to be 0 on a y-intercept. And then, so those are some of my key points. So we always want to consider intercepts key points of any graph. And then for parabolas, we have a unique key point of a vertex. So the vertex is kind of that turnaround point of a parabola. So in real life situations, it's often going to be a maximum point. There are some situations where it's a minimum. If my parabola goes this way, it'd be down here. But regardless, my the coordinates of my vertex, so we can't fill in automatic numbers like we can for intercepts, but we do have a formula for finding the x, and that is based on my a, b, and c values from the equation. So when I have my equation in standard form, so standard form is written out as ax squared plus bx plus c, I use the So it'll be the B and A values here. So if I take the opposite of the B value and divide it by 2 times the A value, that will give me the X coordinate of this vertex. So minus B over 2A tells me where the center of my parabola is, or the X coordinate here. And then for any point on the graph at all, so even if I picked a random point and said here's some xy, if I knew one of these points, or if I know any coordinate, I can always use the equation to find the other one. So like here, if I know the x, I can put that in for my x's. If I know the y, I can put that in for my y. And then for the vertex, once I know this x number, put it in for x. If I had some random point, if I knew the x, put it in for x. If I know the y, put it in for y. So that's a pattern or relationship that we want to understand for any point, any function. Right, so and we are going to be using that to do our algebra work here for this example. So that's our next step, is use the equation to answer questions about this performer being shot from the cannon. So my first question is, from what height is the performer initially launched? So kind of the thinking I want to go through this is what key point is going to give me that information, and which coordinate of the key point is going to give me that information. So if I kind of look at this parabola initially as like telling a story of the man in the cannon. So when the cannon is first shot, we start the timer. So since x is time, that starts at 0. So we actually are going to ignore anything to the left of 0, any negative x values, because we're not going to deal with negative time. So time starts at 0. So this is going to be my start. And we're always coming back to this here, that x is the time, y is the height. So this is saying at 0 seconds, we're trying to figure out how many feet. So for this question, we are going to be using the y-intercept, and the y is going to tell us the height that we're being launched at. So we said that we can always use the equation if we know a value to find the missing value. So I know that I have 0 here, and I'm trying to find y. So I put x into my equation. So we have y equals, and it's negative 16x squared plus 48x plus 10. So I am putting this 0 in for my x's. So I'll put 0 there and 0 there, and that will tell me what y equals. So for y-intercepts, it will, this will typically happen with most functions. Negative 16 times 0 squared, that's just going to be 0. 48 times 0 is going to be 0. And then adding 10, so y equals 10, and that is the y coordinate there, and I can fill it in on my graph. And so that tells me that when the performer was first launched, it was from a height of 10 feet. All right, so we would just say 10 feet. And then we would want to make sure that we have the algebra work to support my answer to that question there. Our next question is, what is the maximum height of the performer? So maximum height is, so since y is height, the highest height that I've reached will be at the vertex. And then again, we want to come back to this right here. The y coordinate of that vertex is going to tell me that max height right there. All right, so this right here is the max height. So the y coordinate of my vertex is going to tell me the answer to this question. So what is the maximum height of the performer? So to find that y coordinate, we actually are going to jump down to this one first. So at the maximum height, when we're asked how many seconds, so that's the answer I'm going to give is blank seconds. So we're still looking at the vertex, and the x-coordinate is going to tell us, so x is how many seconds at that max height. So before we can find the max height, we need to find the x first. So in my vertex, the x comes from the negative b over 2a, and then we'll find the y and do that up there. So negative b over 2a comes from my equation. So here a is negative 16, so it's the number in front of x squared, and then b is 48, so the number in front of x, and my c is 10. And I'm gonna just bring, whoops, this down here. All right, so there's my ABC. So the x-coordinate here is going to be opposite of b. So if b is positive 48, the opposite is negative 48. And then remember, if b had been a negative number, this opposite means that I would make it then a positive number. And then dividing that by 2 times, so that's multiplication, my a value, which is negative 16. And then by Pemdas, I need to get the entire denominator down to one number first. So this is negative 32 under negative 48. And then I divide 48 by 32. And then because I have negative over negative, I know my answer is going to be positive. And it's a positive 1.5. So that tells me that the x-coordinate, so this traces back to there, the x-coordinate of my vertex is 1.5. So he reached his max height at 1.5 seconds. And then to determine what that maximum height was, we are going to plug, so we have 1.5 seconds, the x value into the equation just like we did here to get what that y value will be to go with the 1.5. So y equals negative 16x squared plus 48x plus 10. So I'm just gonna put parentheses there. So I'm gonna replace x in both spots with that x value we got of 1.5. And then we're just gonna do Pemdas to figure out what does y equal. So here we have exponent and multiplication, so I have to do that exponent first. So it'll be negative 16 times 1.5 squared, which is 2.25. Just remember it's 1.5 times itself. And then I can do this multiplication at the same time. 72 plus 10. And then I'll multiply negative 16 times 2.25 to get negative 36 plus 72 plus 10. And then negative 36 plus 72 plus 10 is 46. So that cycles back to here, 46, and then I can go to my graph and put 46 there. So my max height is 46 feet. And again, connecting that to, he reached that max height of 46 feet after being in the air for 1.5 seconds. So that would be 1.5 on the x-axis. All right, and then next question, how long did it take the performer to reach the pool of water? So remember, he was gonna land in a pool of water. And so after he's launched, we look at our height to know when he's gonna land. So we are gonna make some assumptions that the pool of water is right level with the ground. And so he lands when my height is 0, which should be right here on the x-axis. So we are actually going to also ignore the negative y values here. We're not going to have negative height. We stop at 0, which right here is saying we know for a fact 0 feet is an x-intercept, and I am going to use the same kind of thinking we've been using. So now y is 0, and so I'm going to plug into my equation. Let's copy that. So here we're going to have x still, but we're putting 0 in for the y spot. All right, because we're at that height of 0. So then now, this is probably the most algebra of all the questions here. In order to solve this equation, so I'm trying to figure out what values of x, or what time, will give me that height of 0. So I'll go back. So this was vertex, this was the x value, and then now we're looking at the x-intercept, and we're looking at the x value because we know y is 0. So to solve this equation, we learned 2 methods. One method would be to solve by factoring. So if you are able to break this into the 2 parentheses using the box and that whole process, then you can use that zero product property to figure out what values of x make this equal to 0. However, this does not work every time. It only works when you were able to factor this. And so if you want to sit and do the box and try to figure that out, go for it. However, if you get stuck and it doesn't factor, you'll have to come back and do the quadratic formula. So you could just start off right off the bat and use the formula. So that's what I'm going to do. I'm not going to try and factor it. So my A is -16, B is 48, and C is 10. So my formula is x equals opposite of b plus or minus the square root of b squared minus 4 times a times c, and that entire thing is divided by 2 times a. All right, so I'm just gonna go and replace these values here. So my b is 48, so I'm gonna put 48 where those b's were. My a is -16, so I'll put -16 where the a's were. And then my c is 10. All right, so we just get our a, b, c from the equation, and then we plug them into this formula. And then now we just apply our Pemdas. So I typically make my first step to get all of this under the root down to one number. So we have 48 squared minus 4 times -16 times 10. So we'll do 48 squared first to get 2,304. And then we're multiplying 3 numbers here, so -4 times -16 times 10. So 4 times 16 times 10 is 640. And then since we're multiplying 2 negatives here, we end up making a positive, so that becomes addition. And then we add those 2 numbers to get 2,944. So I'm going to go back and just replace that. So 2,944. And then down here, 2 times -16 is -32, so we can simplify that as well. And then our last step would be to apply this plus or minus, so that just means we do this entire thing twice, once with the plus sign, once with the minus sign. So we're going to have 2 separate equations to do. So x equals what was it? Negative 48 plus the square root of 2,944 divided by negative 32. And then we do it again, but with a minus sign instead of the plus sign. All right, so then we can go to decimals, and type in, so we want to make the fraction first, and then it was negative 48 plus square root of 2,944 over negative 32. So my first answer is negative 0.19, but or we'll get the second answer first and then we'll talk about that. So then I change that to a minus 3.19, or round up 3.2. All right, so those are my two x answers. So we actually have two of these. So the 3.2 and the negative 0.19. But if I go back to my graph, so we saw where I had the two x-intercepts here and here. So the negative 0.19, is that it? Yep, would be there, but we already said that we're ignoring that because we're not going to have negative time. So no negative time, so we do not consider that as our answer to this question. Instead, we use the positive 3.2 seconds intercept. So we're kind of ignoring this answer and using that answer. So this tells us that the cannon person will hit the water at a height of 0 after 3.2 seconds in the air. So we're using that one there. And then the last question, what was the performer's height after 2 seconds? So seconds is an x value, so we're looking for where x equals 2. So this would be an x, or sorry. So we're given an x coordinate, and then we're trying to find his height, so we're trying to find a y coordinate. So we're saying at 2 seconds, what's the number of feet? So this is not a key point on the graph. It's not one of the points we already have. It's going to be, so if our vertex is at 1.5, 2 seconds, and this is 3, 2 seconds will be somewhere in this region, and so kind of close to this point here. So we're saying at 2 seconds, what's the height? So kind of that same idea, if I know one value, I can plug in the equation to get the other value. So I'm going to go back to my equation here. I'll use this one. And I'm going to put a 2 in for x. So I'll put a 2 for x, and then we'll do our Pemdas. So negative 16 times 2 squared, which is 4, plus 48 times 2 is 96, plus 10, and then negative 16 times 4 is negative 64, plus 96, plus 10, and then we'll add those together. So negative 64 plus 96 plus 10 is 42. So that y of 42 tells us that after 2 seconds, he was 42 feet in the air. Right? So then kind of just another check of your understanding, make sure that you could explain kind of the story of this cannon man being launched. So like, where does he start? So at 0 seconds, he's launched from a height of 10 feet. He reaches his max height after 1.5 seconds. That max height is 46 feet in the air. And then he starts falling, and he eventually lands in that pool at a height of 0 feet after 3.2 seconds of being in the air.